Hey guys, we're back with part 2 for math for paper 3H from May 2008. I'm Dylan with DylAcademy and let's continue where we left off. So we left off at question 11, and basically what question 11 showing us is a table with a range of pulse rates of 60 different people and shows the frequency of people in each range of pulse rates. As you can see, 80 to 90, 90 to 100, whatever. And question A is asking you to write down the modal class. Now what modal class means, mode means most popular. So modal class means the most popular class. The most popular class means the one with the highest frequency. So all you got to do is look at the highest frequency. In this case it's 21, and that is for the class of 60 to 70. So the modal class is 60 to 70. Okay, well question 11b is asking you to find the mean pulse rate of the 60 people. I think I've done like a question like this before. I didn't do too well, I think, but today I'll try to do it better in this video. So basically mean is nothing but total of all classes, meaning adding up all the classes and all the frequencies and divided by the number of each class. So I'll relate it again to average cost. And average cost is nothing but, let's say, the total cost. So basically it's a total divided by the number of output, so divided by the amount you make. So in this case, the mean pulse rate is nothing but the total of all the pulse rates and their frequencies divided by the number of each class, basically the number of each pulse rate. So in this case, the pulse rates are a range. So what you need to do is you need to take the midpoint of the range to find an average of the mean. So in this case, let's discuss the top one. In this case, it's 60 plus 50 divided by 2, which is just 55. In the second one, it would be 65. Third one, it would be 75. Fourth one, 85. And fifth one, 95. So all you got to do is take this, multiply it by the frequency, and for basically each pulse rate, and then add that all together to get the total. So what you got to do is take 55 times 7, because that's a frequency, plus 65 times 21, plus 75 times 15, plus 85 times 14, plus 95 times 3. I'll just put this all in brackets so it's easier to understand. Yeah, and what you do is you take this all and you divide it by the number of times each class gets repeated, and in this case it's just the frequency table, so it's just 7 plus 21 plus 15 plus 14 plus 3. And if you simplify this whole equation, this massive equation which I've written down, you're going to get a fraction of 4,350 divided by 60, which is nothing but 72.5. Okay, so for question C, basically they've taken the information from above and drawn you a nice little cumulative frequency graph, and they've asked you to find the estimate for the median pulse rate for 60 people. Now median is nothing but a numeric, like in data, it's nothing but numerical values separating the higher half of something from the lower half. So in this case it's the higher half of the pulse rates from the lower half of the pulse rates. So median is just like the middle number kind of. So in a cumulative frequency graph, this goes up, in this cumulative frequency graph, it goes up to 60. So all you got to do to find the median is divide this maximum cumulative frequency it goes up to by 2, and you'll get 30. And all you do is you find 30 on the y-axis, you go straight through it, all the way to the graph, till it touches, and you go all the way down. And basically, wherever it hits the x-axis is the median value, and in this case it's 125. So the median pulse rate is 125. So what question D is asking you is use the graph to find an estimate of people with a pulse rate of greater than 131 beats per minute. So first of all, what you got to do is you got to find the frequency of people at 131 beats per minute, and all you got to do is go up from 131. Sorry, I'm doing this on an iPad. It's going to be pretty bad. Oh, actually, it's pretty good. Yeah, okay, I did that pretty good. So you see the frequency over here is at 48. And then you got to go to the maximum value the pulse rate can go to, basically like the highest value that people have. So in this case it's 140, and you go across, and you'll see that it stops at 60. So that means all the people who have a pulse rate of more than 131 should be in this area. So it's nothing but 60 minus 48, and that'll give you a figure of 12 people with a pulse rate of more than 131. Okay, well in question 12 you're given two circles, S and T, and you're saying the area of a circle S is 4 centimeters square, and the radius of circle T is 3 times the radius of circle S. Work out the area of circle T. Now first of all, these are two similar circles. Every single circle in the world is similar because it's the same shape. So first of all, what is area? Area is nothing but length squared. And since we don't really have pi or anything, this is like kind of like an approximation, because pi is always a constant. So we're just gonna say we're just gonna forget the pi's for now. So the area of circle T is 4 squared. Now so the radius, let's say, of circle S is R, okay? So that means that radius squared is equal to area, right? And radius squared is equal to 4, because the area is 4 in this case. Basically any length squared is equal to area. So that's why radius squared, radius is a length, so radius squared is equal to 4. Now, the radius of circle T is 3 times the radius of circle S, meaning the radius of this is 3r. Now to find the area, all we do is 3r squared, because length, which is 3r, this is length, 3r squared. So it becomes, if you simplify this, it becomes 9, sorry, I have a little bit of a cold today, 9r squared. So r squared from this from this part is nothing but 4. So the area of this is nothing but 9 times 4. And so the area is just 36. It's basically, we can neglect pi because it's kind of like they're similar, and pi is just a constant value, it doesn't matter. So yeah, that's it. Okay, so question 13 shows you a tiling pattern, and they're saying the tiling pattern is made from a regular hexagon, a square, and then there's this other polygon here, which is A. And they're asking you to find the shape of the regular n-sided polygon. Now don't just underestimate this question and be like, oh, it's a pattern, so it should be a hexagon. No. There's a proper way of solving this. First of all, since this is a regular hexagon, it should have an interior angle. And we can calculate this interior angle through this formula, which is 180 n minus 2 over n. And n is the number of sides in the regular polygon. And in this case, this can only be applied to regular polygons. So in this case, it's 180 times 6 minus 2 over 6. So that's 180 times 4, which is 720 over 6, which is nothing but which is 720 over 6, which is nothing but 120 degrees. So this interior angle of the hexagon is 120 degrees. Now, for any square, the interior angle is always going to be 90 degrees, right? So now we know that this is 120 and this is 90. So if you look at this, it's just like you can draw a circle here, and angles on a point around a circle always add up to 360, as you always know. So that means 120 plus 90 plus, let's say this new angle is x, is equal to 360. So this new interior angle of this A polygon, x, this interior angle will be 360 minus 120 minus 90, and so x will be equal to 150. So the interior angle of A is equal to 150. Now, they also say that A is a regular n-sided polygon. So that means that we can still apply this formula over here. Okay? So all we got to do is say that since interior angle is equal to 180 n minus 2 over n, all we got to say is 150 is equal to 180 times n minus 2 over n. And all we got to do is find the value of n to find the answer to this question. So just solve this question for n. Remember to copy down all the working, by the way, because they want to see everything that's happening. So 150 is equal to 180 times n minus 2 over n. That's where we were. So just multiply both sides by n. Multiply both sides by n. And what you're going to get is 150n is equal to, now multiply 180 by n and by 2, is equal to 180n minus 360. Now get all the n's on one side, so subtract 180n on both sides. You get negative 30n is equal to negative 360. Then divide both sides by negative 30. You get n is equal to negative 360 over negative 30. And so n is equal to 12. So shape A has 12 sides. Okay, 14a is a simple question. You're just asked to factorize 10y minus 15. When factorizing, all you got to do is find the highest common factor. In this case, it's going to be 5. And you got to divide each term, 5, and you got to divide each term separately by 5. So 10y divided by 5 is nothing but 2y. And negative 15 divided by 5 is negative 3. So that's your factorized form. Okay, 14b is like similar principles, but a little more challenging. In this case, first look at each part. So look at the number, then look at the p, then look at the q to find the highest common factor. So in this case, the highest common factor between the numbers should be the number 3. The highest common factor between the p's should be p. And the highest common factor between the q's should be q. So 3pq is taken out. And basically you divide everything by 3pq. So 9p squared q divided by 3pq is 3p, and 12pq squared divided by 3pq is 4q. And so that's it. Alright, so next question, C1, you're being asked to factorize a quadratic equation. Now we've dealt with a lot of quadratic equations, so I'm going to rush through this. So basically you're looking for two numbers that add to give you 6, and two numbers that multiply to give you 1 times negative 16, which is negative 16. So two numbers that add to give me 6 and multiply to give me negative 16 is nothing but minus 8 and plus 2. So minus 8 and plus 2. So all we got to, plus 8 and minus 2, my bad. Again, silly mistake. So x squared, you just got to split this part into plus 8 and negative 2, plus 8x minus 2x minus 16. And now again, like how we've done it before, just take each side separately, factorize each side separately. In the left side, the common factor is x, so you take x out, x plus 8. And on this side, it's minus 2, and in this case it's x plus 8. Now all you got to do is factorize x plus 8 from the whole equation, and you just get x minus 2, because x plus 8 x plus 8 cancels, and you get x plus 8, x minus 2. So yeah. Okay, so next question, you're asked to solve x squared plus 6x minus 16. Now when they say solve, you're basically being asked to find two values of x. So from the previous question, when we factorized it, we got x plus 8, I think, and x minus 2. And so we factorize it to that, and you make that equal to 0. Now what you do is, you're going to get two answers. So basically, if you're going to try to solve this x, you're going to divide both sides by x minus 2. So divide by x minus 2, divide by x minus 2, and these two cancel, and 0 divided by x minus 2 is 0. So you're going to get x plus 8 is equal to 0. And so x is equal to negative 8. And if you do the same for the other one, so x plus 8, x plus minus 2 is equal to 0. You divide both sides by x plus 8, you're going to get x minus 2 is equal to 0, and so x is equal to 2. So your two solutions are x equal to negative 8 and 2. Okay, so in question 15, they say that Mia's weight is 57 kgs, and correct to the nearest kilogram. In 15A1, they're asking you to calculate the upper bound of her weight. Now, first of all, correct to the nearest kilogram, meaning it's correct to the nearest ones place, right? So that means all you got to do is take the 1 in the ones place and divide it by 2, and you'll get 0.5. And now to find the upper bound, all you got to do is add this 0.5 to 57. So you get 57 plus 0.5, which will give you 57.5. And if you wanted to calculate the lower bound, it would just be 57 minus this, and so it would be 57 minus 0.5, which is 56.5 kg. And it's basically, upper bound and lower bound are just basically limits. Basically, when her weight was being rounded to the nearest kilogram, it could have either been 57.449, which is just 57.5, rounded down, or it could have been 56.5 rounded up. So that's what upper bound and lower bound basically is. Okay, question 15b is asking you to find the upper bound for the difference between Alice's weight and Mia's weight. Now, if you were going to find the difference regularly, you just do Alice's weight minus Mia's weight. So 62 minus 57, which would give you 5 kgs as the difference. But in this case, they want the upper bound. So if you were going to find the upper bound in subtraction, all you would need to do is take the upper bound of this, so basically the upper bound of what the first number, and you would need to subtract it from the lower bound of the second number. So you get a higher number, right? Because if you subtract a bigger number from a smaller number, you're going to get the higher number. So in this case, you got to find the upper bound of Alice's weight. And so Alice's weight is 62 kgs to the nearest kilogram. So the upper bound is taking the ones place. The ones place is 1 divided by 2. And you take the ones place, you divide it by 2, and you get 0.5. And all you got to do is add the 0.5 to 62. So the upper bound of her weight is 62.5. And now the lower bound of Mia's weight was, we saw it before, it was nothing but 56.5. So therefore the upper bound for the difference should be 62.5 minus 56.5, and that'll give you an answer of 6 kgs as an upper bound difference. Okay, so question 16 says that there are 9 cards, and Lee, this guy, takes a card at random, and he records the number which is on the card and he replaces the card. Basically, replacing the card means that he puts it back into the pile. And then he takes the second card and he records the number which is on the card, and then whatever. So 16a is calculate the probability that he'll take 2 even numbers. Now first of all, when he's picking out the first card, right, what is the probability that he'll pick out an even number? It's basically the number of even numbers there are, so 20, 22, 24, 26, 28, divided by the number of cards there are. So there are 9 cards, and there are 1, 2, 3, 4, 5 even numbers. So the probability of him picking up an even number on the first pull will be 5 out of 9. So let's say he picks out an even number, then he puts it back in the thing. And then he's going to pick out again. So he still has the same numbers in the pile again on the second pick. So that means the probability of him picking an even number will stay the same, because there are the same amount of cards and the same amount of odd cards and even cards. So that means it's just 5 over 9 times 5 over 9. And that just gives you an answer of 25 over 81. Okay, so for question 16b, you're asked to calculate the probability that you will take 2 numbers with a sum of 43. This is a bit more tricky, but it still applies the same basic principles. Now, what are the ways in which you can get a sum of 43 in those 2 picks? If you first pick a 20, and on the second pick you pick a 23, you'll get a sum of 43. If on the first pick he picks a 23, then on the second pick he picks a 20, he'll still get a 43. Then if on the first pick he picks a 21, then he picks a 22, he's going to get a 43. Or if he picks a 22 and then a 21, he's going to get a sum of 43. So there are 1, 2, 3, 4 possibilities. Now let's calculate the probability of the first one happening. So what's the chance he's going to pick a 20 on the first one? It's 1 out of 9. And then on the second one, what's the chance of him picking a 23? It's again 1 out of 9. So basically it's just 1 out of 81. And now the same thing can be applied to the second one, because think about it, it's just 1 out of 9 again times 1 out of 9. So it's just 1 out of 81 again, because again there's only one card. And the same can be applied for the third and the fourth one. So to find the total probability, all you're going to do is add 1 over 81 4 times. So it's just like multiplying 1 over 81 times 4. So it's nothing but 4 over 81. It's because to find the total probability, you're going to add 1 over 81 4 times. And adding 1 over 81 4 times is just simply multiplying 1 over 81 times 4. So that's it. So in question 17, they're saying the distance d is directly proportional, this is the symbol for proportionality, to the square root of the person's height. So square root of h. Now if we were to put this in algebra, it would be d is equal to a constant times square root of h. Now in question 17a, they're asking you to find a formula for d in terms of h. So you have d is equal to k times delta h. Square root of h. So all you got to do is find k to find an equation, a proper full equation. So they're telling you that when h is 225, d is equal to 54. So just substitute those values in and you can find the value of k. So 54 is equal to k times square root of 225. So 54 is equal to k. Square root of 225 is nothing but is nothing but 15, So it's nothing but k times 15. So all you got to do is divide both sides to find the value of k. So k is equal to 54 divided by 15, and which is k is equal to 3.6. And so your final equation is d is equal to 3.6 times root h. And that's it. Question 17b is asking you to calculate the distance of the horizon from a person whose height above sea level is 64 meters. So h is just 64. So all you got to do is just substitute h into this equation, and you'll get a value of d, distance from the horizon. So d is equal to 3.6 times square root of 64. So d is equal to 3.6 times 8. And so d is equal to 28.8. 17c, just as simple as 17b. They're telling you that the height, find the height above sea level of a person whose distance from horizon is, so distance is equal to 61.2. So all you got to do is substitute this into this equation. So you're going to get 61.2 is equal to 3.6 times square root of h. Divide both sides by 3.6, so square root of h is equal to 61.2 divided by 3.6, which is 17. And h is equal to, so you basically just square both sides, right? And you're going to get h is 17 squared, which is just 289. Okay, so thanks guys, we're done with part 2. Please comment if you have any questions, and also rate and subscribe. I'm sorry, but I'm a bit sick today, so like my voice is a bit hoarse and stuff. So just keep watching, and please watch part 3. Thanks.